Okay, in the last integration annihilation video, got a little angry in the end. So sometimes that's what you gotta do. You gotta get a little angry, you know? And you gotta get after them. So what do we got right here? We got the integral of 4 raised to the square root of x multiplied by, divided by 4 times square root of x. That's pretty weird. But let's rewrite it. Let's just, I'm gonna rewrite it. Here's how I'm gonna rewrite it. Okay, that looks a little sloppy, but it's just 4 raised to the square root of x multiplied by 1 over 4 to the x, or 4 times square root of x. That's the exact same thing. And I'm going to do something else. 2 times 2 equals 4, right? Well, I'm going to factor a 2 out of here, okay? I'm going to factor a 2. Actually, let me just do it like this, and I'll write it a little bit cleaner while I'm at it. There we go. So I got 1 over 2 times 2 times square root of x. So what I'm going to do, I'm going to yank a 1/2 out of there. Now what does it look like I got? Oh, you can't see it. Okay, it looks like I have a derivative of square root of x, doesn't it? And that's a tip-off for the u substitution. So let's go ahead and let's just call u equal to square root of x. U equals square root of x. Du equals 1 over 2 square root of x dx. That's our good old rule. Okay. Ooh, and I forgot to write my dx over here. My math teacher's gonna kill me. All right, there we go. So here we go. Well, here's here's du right there. So let's just rewrite this. We got 4 to the u because we made the substitution. Okay, and then dx. Well, du is equal to this jobble right here. Du. So here we go again. Let's just rewrite this as e to the natural log of 4 to the u times du. And I see a logarithm power rule coming on. And we're just gonna, stick that bad boy right in front of there. So now we got e to the u to the natural log of 4 du, and I ran out of paper again. It's all right. Integration annihilation sometimes requires you to annihilate some paper as well. Okay. Now I'm gonna rewrite this again. Okay. Now this kind of looks like one of these e to the 4x type things, right? And we know that the integral of that's 1/4 e to the 4x plus c, of course. So this is starting to kind of look like that, except remember, log of 4, natural log of 4, that's just a constant. So it looks like the constant out here stays the same, and our integral of this is 1 over natural log of 4 times e to the natural log of 4u plus c. Okay, let's see if we can't clean that up a little bit. Tell you what, I'm going to first clean it up by doing a little reverse power rule. Okay, I'm going to take, remember this thing was grouped, so this u, it doesn't matter if I stick it in front or behind, it's still going to go back up here on top of the 4. So let's just go ahead and rewrite it that way. Plus c, and if you remember back from in the day when you were an algebra student, or maybe you were paying attention to some of my algebra videos about logs that I just put on not too long ago, you know that this business cancels out, basically, and leaves you kind of with, you know, something that looks like this. Let's see. Okay, now let's take it a little further, clean it up a little bit more. Now we got 1 over 2 times natural log of 4. I just put the, and actually this will be just 4 to the u plus c. So we're just there. You know, that's no big deal. If I wanted to, I guess I could take my power rule again, and I could stick this 2 up here and make that 4 squared. Okay, and that would give me a 4 to the u over natural log of 4 squared is 16 plus c. And remember, originally my u substitution problem said u was equal to square root of x. So we can go 4 raised to the square root of x over natural log of 16 plus c. Final answer. Okay, see you in the next video. We're just, like I said, man, we're just gonna knock these things. I'm gonna set them up and knock them down. Okay, and just like cocktails on a bar stool. We're just gonna have a party. We're gonna annihilate integrals. You know. See you in the next video.